Happy New Year, everyone. So today's topic is to do with SwiftUI OCR. So if your SwiftUI OCR app doesn't cache or hash images or persist scans, it's not a production ready app, it's more like a demo. Most tutorials work this way, as a demo, and then it breaks in a real app. Here's how I built a real OCR app in SwiftUI. As you can see, the user, they can select their image that they want to extract. And then the information, including the image, is stored in SwiftData. And it also shows the confidence on the detail screen. So this is the app feature that we'll be looking at today. The OCR service. So the purpose of the OCR service is to handle text recognition to enable the application to extract text using the device. So we need to create a protocol and also a struct. And then after that, we need to create another file that is called Vision OCR service. So the Vision OCR service contains a method called recognize text. Vision gives us OCR and we bridge it into async await. This wrapper is fine, but we're not treating it as OCR configuration as a first class signature, meaning caching can become very incorrect and error prone. But we can change this later within the production version of this class that we're implementing. And also after lines 47, we're using accurate recognition and language correction. Why this isn't production? Because these are hard coded, as you can see. If you change them later, your cache results might slightly become wrong for the new config. Production avoids this by providing a more better storing mechanism. So this is the updated version of the production Vision OCR service class. As you can see, the updated part is the recognize text function. So what we're doing here, Vision is a callback base, so we bridge it using async and await. And this also gives us cancellation points and structured concurrency, which is much more cleaner than using traditional error handling. On lines 50, we configure Vision from the signature. And because the signature is stored, the cache validity stays correct even when we change these later. For image hashing class, we need to import CryptoKit. The image hashing class has a single function called hash. We hash the image so we can do cache lookups. And the reason why this isn't production ready, this hashes the raw CG image bytes. This can be unstable across different encoders, formats, metadata, and also color spaces. And there's a variation in pixel formats. So the result of the actual photo or image can be random because the hash may not be the same. So the production fix is by hashing a normalized representation like a JPEG or a PNG file. The next file is the OCR repository. The fetch result method hides SwiftData's details from the view model. And the reason why this isn't production as yet is because we're performing cache lookup, which is only by hash. In production, you also filter by processing signature key to guarantee the correct cache. And here is the updated OCR repository file. As you can see, most of the update has happened in the fetch result function. Cache hit requires both hash and processing signature. That's what makes the cache correct. And also within the save method, repository owns persistence. In the next tutorial, we will focus on the OCR screen and the OCR details view. If this topic is where you keep getting stuck in SwiftUI, that's exactly what I help people with in one-to-one mentoring. There's a free clarity call link in the description.